Hello everyone, my name is Musad Mansour and I am going briefly present to you my graduation project. The title is Changeable Password Proportional to Time. So basically it's a continuation to to the previous semester design. So you're gonna be familiar with the idea behind this project and for some of the slides in this presentation. So let's start. So basically, the idea behind the project, as you know, it's my passion to math and numbers, as I said, and the cryptography methods, and also the logic design and digital system course, which I had last year. So give me that. It's the biggest. It's basically the idea behind this project. Um, so and now the current situation right now about the idea about the project is basically right now, as we said, we have a simple password system, which it is about like, for example, a four-digit password. It's really simple, such as the phone lock screen and the smart houses, and for money safe in the hotels rooms, for example. And the other part is the more sophisticated password, which is basically about the online accounts, the banking, and emails, which requires like numbers and some other alphabet, capital letters, small letters, and other symbols. And for both cases, they have some advantages and disadvantages. For example, the simple password, its advantage is so very simple, but the disadvantage is it's easy to hack for according to the possibilities and probability for the numbers. On the other hand, the more sophisticated password, it's really hard to hack, but it's not so much comfortable for the users. For example, uh, if for some users they make an account password for some account they use once a year, they make it a complicated password, but later they make it for one time and later they forget it. So when they had to use it again, for example, later they didn't know the password, it's gonna be like a long process by sending an email to another to make a new password, so on. So basically, the idea came up to combine these two kind of password into a different idea, like make it simple password in one hand, and the other hand is also safe. That's why we create a changeable password proportional to time in our to a new system like in the security system. I'm sorry. So the project we made it's consists of two parts. First of them, well, the first one is the main part, which is based on the logic design and digital system course I took. And the second part is about the smartphone application, which is about computer science and Android and downloading and something and so on. Before we continue, the password actually comes in a cryptography theorem. It's actually a simple one about additional equation, which includes two parts. The first part is called the enter key, and the second part is the clock. So that's why the title came like this. It's a proportional to time, so the clock represents the time, and the enter key is the first enter number or like the first like a password or you can say the secondary password of the system. So, so moving to the main part first. The main part is constructed by four elements. The first one is the seven cycles. Why it's seven? It's because of the possibilities we have. Forgetting to mention is the enter key must be a number between 0 to 6. I will explain why 6 only later. It must be so from 0 to 6, the enter key must have 7 possibilities. So, and each possibility and each cycle actually have an equation inside by using the mathematical part, which actually explain in details in the reports. So that's why we call the 7th cycle. The second part is the 3 times 8 decoder. It's 3 inputs and 8 output decoder. It represents the enter key. So we have 7 cycles. So it must be connected to 7 output from the decoder. Each output from the decoder represents one of the possibility cycle. The third part is the IC counter, which is responsible on the counting signal. It's actually going to be the input for the 7th cycle according to the time. And the fourth part which is the 5-5 timer, which is connected to the counter that give him the pulse signals to still continue on depending on its frequency. It can be 5 minutes, like count after 5 minutes, count up for IC counter, or like 10 minutes, or 30 minutes, or 60 minutes, depends on the digit and the order we give them. So the structure of the main device, I will explain it like what I explained now, a short time, and like in the previous slide. It's first, the users choose an entered key from 4 digits, whatever comes to his mind. And I said it's going to be from 0 to 6. The reason behind 0 to 6, it's because of the final output we are going to have for each digit is going to be hexadecimal number. So it's going to be a numbers from 0 to 15, or you can say from 0 to F. So because we have only an addition equation, we make the clock a loop from 0 to 9. So a maximum number for the clock is going to be 9. So in order to not reach after the 15, so the maximum possible for the enter key can be only 6. So that's why make it only from 0 to 6. So let's continue. The enter key, the user choose the enter key from the beginning to start the device. Since the time the user sets that enter key, the clock start to work. So when the enter key is so that the enter key can actually as an input for the decoder. The decoder sends the signal to the 7th cycle, and which cycle should work from the 7. If the enter key, for example, for the first digit is going to be 5, so the 5th cycle, no, the 4th cycle actually, not the 5th cycle is going to be cycle number 4 because it starts from 0. Is the one actually we're going to need its output. And on the other hand, the decoder since make it the enter key, send the signal directly to the 5-5 timer to start count, and to the IC counter actually is going to will be sent it to the clear part. So that means we started from the 0. So the timer start to run. This is the first pulse. The beginning also for the counter is going to be from 0, 0, 0, 0. After amount of the time, depends on which frequency put in the timer, it's in a cycle, a single pulse signal, a pulse signal, and then the IC counter counts up by 1. On the stationary part, if it's not counting up still, so the output is going to be the first part of the cycle we choose. So when it's count up, it's another signal to the 7th cycle for each input, and basically the cycle we choose by the decoder take the input from the counter, and its output is going to be send it as an output for the end and reach the comparison part, where actually the part that the device compare its signal from where the signal comes from the user or the one to access device. So here actually in diagram, and here how the device looks like. So I know it's kind of complicated to explain, but let's make it simple here. Here we have 7 breadboards. Each breadboard represent the cycle. It's one the first cycle, the 0 cycle, I mean, first, second, third, fourth, fifth, and the sixth. So totally 7 cycles. And each cycle has an input from the IC counter, as we said, and here's the IC counter. It's in the signal for each one. And the IC counter connected to the 5-5 timer, which is actually here. And this one actually is a NAND gate, which is actually connected to the IC counter to make the loop from 0 to 9. That's about looping. It's also explained briefly in the report. It's explained in details in the report. And here, also here the last part of each, the left side of each breadboard, we have an AND gate, which is actually a connection for all the cycle output to the decoder, because the IC counter send the signal for all the cycles, and all cycles has different outputs. But in the end, in order to choose one cycle, we must connect an AND gate for each one with a decoder. On the decoder, and we know that the decoder makes all the output as 0, like as a low signal, and only one single signal is going to be high, which is the signal we want. So if it's all of them connecting to a 0 signal from the decoder, so basically the answer is going to be all of them 0 except the one we choose. And in the end, all of the 7 final outputs from the 7 cycles will be connected in an OR gate, 8 outputs. Yes, 7 input OR gate. Where here is going to be the datasheet is going to be 4078B, sorry, and it is an 8 input NOR OR gate. And basically, after we find the answer, the final output, it will be sent that the comparison part, which we said. Here's the comparison part. The comparison part, it's what the signal comes from the users, actually. And the comparison is going to use an equivalent gate, which is XOR NOT. So XOR NOT is going to be high if it's the both inputs are the same, and will it be sent low if it's not, if they are different. So basically, if the signal comes from the device similar to the signals comes from the user, which means the password is going to be correct. So which is going to be send a signal here actually to the green LED here. It's correct, and the same signal also will send to the NOT gate, which means if it's wrong, so it's going to be low gate to the NOT to make it high, because we know the both LEDs must have high signal in order to start. So that's why it's like a simple like formula outside of the box here. So here in the picture, we're gonna have unfortunately, we're gonna have all the time like red LEDs due to the capacitor and resistor in the 5-5 timer. According to the equation about the 5-5 timer, we're gonna have a time cycle or frequency every like 0.1 seconds. So the counter counts up every 0.1 second. So which in the loop of 10. So which means in each second, the output is gonna be low, it's gonna be high for only for 0.1 seconds, and I'm gonna be low, which is mean wrong, 0.9 seconds. So it's impossible to see it in the eyes on the LED in 0.1 second lighting red green, but that's how it's gonna be. So it's gonna like a light green only for 0.1 second, and the rest is gonna be 0.9 seconds. So if we have like a higher amount of capacitor and resistor, we're gonna have a larger time cycle, and we see the difference when we see the green lighting. So, and that was about the main part. And then the main device, moving to the smartphone application. We all know that the smartphone came to make the calculation and give the information for the user to use the correct password in order to access or like get inside to access the device, get approved for internet. So the smartphone application is based on like here as in the photo in like 3 pages. Here is called CPPT. I named it after the name of the title. First from the title, changeable password proportional to time. The second page shows the enter key we choose, the current password at that time, and with a hidden, actually with a hidden like a clock. You want to show it just for the safety. And here there's a button called change key. When you press the key here, it will open to another page. It shows the possibilities for the enter key if you want to re-change the key number. And for the time, after putting the numbers, it's start key and set key. The time you set the key, the clock runs again, and the equation goes back again, and the process is gonna back from again. That's what is about the hardware. And the software part is like a simple equation. C equal T over Di mod 10. So that's what it's gonna be. C is the counter position output. T is the time in minutes. And Di, the constant for the digits. So that means that it's going to be like 5 or 10 or 30 or 60. That's the difference. That's the meaning of the constant. So, and the mod tell it the remainder of 10. Here the PI is C plus KI. Okay. So here basically we take the time and the clock when the user wants to access, divided by the constant. Let's forgive it, for example, like if we pass like a 2.5 hours, like 2 hours and let's say 2 hours and 23 minutes. So the time is gonna be in minutes. The 2 hours has 120 minutes plus 23 minutes is gonna be 143 minutes divided. Let's say it's the first digits, which means every like hour. So divided by 60, so it's gonna be 2. So we take only the integers here from the 2. Mod 10 is gonna be only 2. So the C is gonna be 2. So it's C gonna be 2. And here the PI is the final password, KI is the entered key password. So the PI, which means P for 1, because we choose the 60 minutes, is gonna be 2 plus the enter key. If we choose the enter key as 5, for example, 2 plus 5 is going to be 7. And here's the final equation for the whole process. PI is T over D mod 10 plus KI. Let's give another example. For example, we want to choose the second digit, which is basically change every 30 minutes. And for the same clock, we say 2 hours and 23 minutes. So how many counting is going to be? So T over Di, we said 120 plus 23 is 100. And 43 divided by 30, it's gonna be 4 as an integer. 4 mod 10 is gonna be 4 plus the KI. Let's say also for the 10 minutes. Okay, 143 divided by 10 is gonna be 14 as an integer. 14 mod 10, it's gonna be 4. Also 4 plus the KI. And so let's continue so on for the 5-minute thing. 143 divided by 5 it's gonna be 28. So 28 more 10, it's gonna be 8. So 8 plus ki. So basically, we from the equation is gonna be next. We never reach a number more than 15. It's gonna be f. For example, if the c was 8 and the k was 6, 8 plus 6 is gonna be 14. 14 is e. So that's how the equation goes from the software again also. So going to the results here again. The results gonna be depending actually on the enter key, according to the diagram here. If the enter key is gonna be 0, so the final password is going to continue by looping from 0 to 9 because of the clock. The clock is counting from 0 to 9 plus the enter key. So the possibility for the enter key is 0 is gonna be from 0 to 9. If it's 1, the enter key, the limit we're gonna have from 1 to A. If it's 2, from 2 to B. And continue so on. When it's 6, it's gonna be the minimum is 6, and the maximum is gonna be F. So the final password is gonna be an hexadecimal number, but the looping of the possibility is gonna be a loop of 10, not a loop of 16. So that's the only difference, depending on the time again. So final as conclusion, it's the same conclusion from the previous semester. We made this project. It's like a new technique password system. The password turned from permanent to changeable. So it's the technique. It's like having a different changeable password instead of permanent password. And also for the aim, the biggest aim is make it a simple password with no need to memorize. So here, which means like by having an application that make the whole calculation and give you the answer, no need to memorize the password. Just open the application and check the password, just set it up on the device, and you'll get their access.